Hello, welcome. My name is Jens, and I used to be an e-science engineer at the e-science center. Um, I also used to be one of the main developers of votca because I used to do my PhD and my postdoc. If you come to votca, you probably will either end up like the first thing you'll ever meet is this page or this page. Let's start here from the website. Votca has two main parts, that's CSG and XDP. Tools is basically some common things that are used by both to some extent. CSG is the coarse graining thing that's mostly maintained by Christoph Junghans at Los Alamos National Laboratory. The other one is XDP, which is mostly maintained by the Baumeier group at Eindhoven University or Technical University. I encourage you, before you do anything else, look at the installation. Yeah, you'll see that there is a couple of dependencies you have to install. You'll find the things here. And otherwise, this should basically get you to where you want to go. Preferably master branch, I guess, for the things, for the development. So the manuals are actually not that interesting. I would encourage you to do the tutorials. Probably in your case, you'll probably work at the XDP, so I genuinely would encourage you to do the QMM and do some of these tutorials. It helps you to understand what the inputs and outputs are of votca, how it handles options, etc. That already tells you a lot about the code. In general, I'll show you here. Basically, votca as described here, you have to first source a votca.bash, which sets the correct folders. And then you have commands like this where you run XDP tools. And XDP tools is basically a library thing that calculates individual calculators as this one. There's a lot about option handling, parallelization, etc., which we'll come back to later. If you want to write option files, it's all XML files. So that's like the mainstay of votca. There's a couple of more things. How to serialize things. So like the thing where we basically write all our outputs to is HDF5 files for various things, and you can also use those. That's something we also handle internally, where we have like some nice library wrappers. So that's that part. Also interesting to see is the developer and contributor guide. There's a couple of things you'll see. At the moment, some of the documentation is outdated concerning this because we just included all the individual libraries which we were separate repos into one, and you'll probably still see some remains of that. Nowadays, it's much easier because it's all in one repository and basically can work on it as every single other repository. But this is still relevant. Types, IDs, units, indexing, that's still very much important. As well as website documentation, which we use swings, etc. to build this website. Also GitHub, of course, that's where we go next, to the votca repository. Side note, I probably, at the moment here, the README is not updated correctly. But here you'll find actually we have, if you go to XDP, you'll see that there's a Slack channel. This is this one. I strongly recommend to you to have a look at this because there's like the people you have to talk to if you want more help. You also have the Google group. Could be also interesting. If you look at the badges, they hopefully will be moved to the main file. But then we have code coverage. We have a CI. We have a DOI. We have code quality tools. So lots of things are there. General structure, it's mostly C++, a bit of Python, a bit of Bash here and there. But like there's a couple of things I'm quite proud of. So we use issues, we use pull requests to the thing here. At the moment they are text XDP, but that might go away. But we have like a rich setup of CI. So this is our main CI run here. We have a bot which adds to the changelog, creating PRs. This will all still slightly be reformatted. We also have a GPU runner which is hosted at TU Eindhoven to run calculations which use CUDA support, because we support CUDA. Otherwise, the build system, as you may have seen already, is CMake. So everything is done via CMake, and it's a pretty modern standard. So yeah, that's that. We also support the Intel compiler, the Clang compiler, or the Intel compilers, I would have to say at the moment. So ICPC and ICPX, I think, is the new one. We support Clang and GCC. We also support linking to MKL for faster things. Otherwise, the everything, all vector and matrices stuff is eigen matrices from the eigen library, which we use as all of that. So if you have to do numerical stuff in votca, probably the eigen documentation is the place to go. Yeah, at the moment we are also on the C++, we recently upgraded to the C++ 17 standard. Yeah, so please use that. Yeah, you can use anything from the C++ 17 standard. What else? So yeah, code review, etc. That's all things we do the correct way with, like, everything is fine there. So let's look at a couple of things here. So we have, yeah, I'll skip sort of CSG and CSG tutorials because you probably will not have that much with it, but yeah, feel free. So we have the CMake modules is basically finding specific external functionalities we may not have, which CMake doesn't have support for at the moment. Yes, CSG is the cross-grain library, CSG tutorials. Share, we have basically the start of our doc, so we can build our web page from it, and format is basically how to make the yeah, to run the make format, because that's basically format everything with Clang format. As you see here, we have that as well, so everything is formatted correctly, and if you don't format your code correctly, it will be rejected. So that's share. So let's dive into tools, because it's basically the same as all the other ones. So we have basically, it's all divided into a couple of things. We have the share folder in which you share things for the doc, the man pages. We have scripts. All scripts basically are with the .in, and with the .in, and then by CMake they are converted into the bash, where you then add the correct GitHub token, etc., etc. You can see that here, for example, that then it basically, here we fill in the project version and Git ID, etc. via CMake, so that it all has the correct Git steps. So, but apart from that, so that's the scripts thing, which basically normally Bash or Python scripts for what you have to do. It's like small things, it's not the library. We have the C++ is basically in source and include. So in source we find 3 folders in between. That's the lib folder, where basically all the CC files are in. That's not entirely true. So all the CSG tools and XDP basically work in the same way. One is a library, and there's a couple of small executables which are using parts of the library. So here for tools, basically we find them in tools, and there's, in this case, there's only votca property CC, which has a main. Yeah. So it's always the same thing. Everything else is built into a library. We also have tests for many files. Yeah, they're named test underscore class name. Yeah, for those, yeah, you see the CMake. We use Boost testing framework. You can use anything from that. Also, each test gets a tools. No, that's tools test data folder. It basically gets, I'll show you in a moment. If it's here, you won't find it. I know my matrix, that's probably a good one. Yeah, we have a tools test data folder. Actually, we do have that. So each tool, you can actually create data files for the specific, and actually could put in a matrix market format files in here, or any kind of files you need for that specific test to run. So you don't have to put all the stuff you use for unit test into the source code. You can just put them into the data files if it's just files. It makes compile times and everything smaller. Yeah, so tools, source, we go back, we have the tests, we have the executables, and we have the library. In the library, yeah, there is just the individual things. Coding style is not super coherent, but yeah. So that's tools. Tools depends then on CSG depends on tools, and XDP depends on CSG and tools. Let's go into XDP because that's also one you will probably work the most in. We have, you see same thing. The header, the include votca XDP. There's all the header files which will later on be installed. Nearly all header files are installed at the moment. It's the way it is. Let's go into a little bit into the structure of how, if you have done the tutorials by now, you should know that basically votca XDP at least is based on a lot of calculators. So if you look into source here, and we look into tools, you'll see that there's 4 different executables. XDP map is a bit special because it's just one thing, but all the other 3 basically main file, they run a list of calculators. So XDP parallel is probably the most difficult one, but basically you will run a calculator. So yeah, we have this. XDP parallel is a state application because it has to read state files, which we'll come back to later, or we won't probably come back to later. It's basically HDF5 files which are used for large scale things. Read the tutorials, you'll understand. But basically the idea is like, XDP parallel can run multiple different calculators, so basically it has different options it can do. And for that, it basically has a factory which creates an creates like a derived class of the job calculator class. But for that we use a factory. All the factory things you'll find in libxdp, for example, in this case. Job calculators, you find the individual job calculators, and which all have the same interface, and here you'll find the factory for it, the job calculator factory, for example, which has like registered all of these calculators. So that's like the idea. So in general, we use a mixture of templates and actually also like inheritance. So that's not fully nicely structured there. Inheritance we mostly use for the calculators, and a little bit also for QM packages. So votca in general allows you to interface with different QM packages, which we'll see here. And there's at the moment actually only 2. It's the orca QM package, which is open. It's a freely available software. It's not open source. And the other is XDP DFT, which is a DFT package that we wrote ourselves. So it's the internal implementation, which is not as fast as orca and it doesn't have as much functionality. And then we use like factories for a couple of other things as well. So what these folders mean, that's sort of like to some extent it's arbitrary. There's in some cases there is some grouping, other cases there is not. It's, as I said, it's all CMake lists. So if you add a file here, you'll be fine. I'm struggling to say what's the structure of this, because it all depends on what you're trying to do. I think like for the QM part, something that's sort of really important and it shows you a couple of interesting things is orbitals. And I'll come to that orbitals object in a moment when we look at our editor. So we are in the orbitals class. So that's basically the place where all QM information for QM calculation or DFT GWBSE calculation is stored. It's going to be hopefully refactored again a little bit in the future. You see like a couple of general things, and actually we should use Doxygen in documentation, which you can also find online at, you'll find it if you look at votca. Votca, votca, share, doc, developer's guide. You'll find the thing here. You'll see, okay, there's actually all the things, including namespaces. And then tools, votca, XDP, for example, you see all the overview of all the different classes. Yeah, let's briefly talk about parallelization. No, let's talk about orbitals first, and then we'll talk about parallelization. Yeah, so it's a big class. It stores way too many things, but basically it's all about yeah, the DFT and GW calculations. As you see, for example, yeah, we can also return by reference, but the eigen data structures is what we use mostly for numerical things. Interesting to see is many larger classes have this write to checkpoint file, read from checkpoint file, either with the writer or in this case also a file name. And that basically allows, that's basically the interface to HDF5. So if you go to the CC file, I hope that's, yeah, here the CC file, you see, okay, you can read basis set, and that's with the keyboard basis set size. So it's HDF5 files. You can read HDF5 files with HDF view or HDF compass or like files like that, readers like that. You can actually realize them, which is very nice. And you can read them with Python, etc. So lots of nice things you can do. Yeah, and this basically contains all the information about orbitals. So like all the QM stuff somehow pushes orbitals around. Let's look at parallelization briefly. And that's slightly more difficult. So there's basically two levels of parallelization in XDP, and it's one is XDP basically calculates properties on a molecule or a pair of molecules sometimes, but XDP also allows you to, if you have an MD simulation with lots of molecules, to do that in parallel. So if you have 1,000 molecules in your box, XDP allows you to calculate things in parallel in all of these molecules. Or yeah, that kind of parallelization is done using p-threads. That's the old C kind p-threads. Then, of course, inside all these calculations, for example, if you look at GWBSE, for example, RPA, that's something that's used inside the thing. You'll see, where's the work? RPA is something that's used in the GW calculation. You see actually OpenMP parallel that's used there. In this case, actually, the dynamic. We only use basically mostly schedule dynamic because these days we have like 40, 50, 60 cores, and anything else but dynamic doesn't really work out well. And you see it's all matrices. It's all eigen things. What else I wanted to say about this is so there's these two levels of parallelism, and that's at the moment it's a clusterfuck in a sense, because XDP parallel is the only thing that actually uses p-threads. Everything else only uses OpenMP because all of the other things only work on a single molecule at the same time, so that's fine. Or do a single calculation that's internally parallelized with OpenMP. So that can be unpleasant. There is two more things I want to talk about. Yeah. So for some parts, and you see that actually here, here's like these calculations over OpenMP. But here we also have this OpenMP CUDA object. So some of the OpenMP threads actually do work depending on in which thread ID they are. You can see that here. Some of these OpenMP threads actually don't use CPUs, but actually use the CPU to serve GPUs. So to some extent, OpenMP and CUDA interact. You can also use multiple GPUs, etc. How does this all interact with p-threads? Yeah, it doesn't really. So that's like one of the things that are not really well thought out at the moment. So parallelization is still something that votca lacks to a certain extent. If you look into OpenMP CUDA, I'll just briefly show that. It's not like a language that sorts these things out. It's basically just hiding the implementation for doing specific things. That's the wrong window. Yeah, OpenMP CUDA, you see actually. Here, for example, is one where you multiply, right? For example, where you multiply a matrix with something else, and you see this is the implementation for the CPU, and here's the implementation for the GPU. So not everything is parallelized in the GPU, it's only specific operations, which seem to be the most bottlenecky ones. There's lots of problems here with like what is a temporary, how do I copy something to the GPU and when to copy it. Yeah, there's quite some involved things, but it always involves sort of like if they've used CUDA, then do this. Like here you see it actually better. If you use CUDA, do this for the first couple of threads which serve GPUs, otherwise do the CPU operation. And if we don't have CUDA, just use the CPU operation. So that's this part. There's a lot more to go through. There's lots of classes. Mostly XDP is using like value-based design, so just copy things around. You don't have to do all pointer stuff. As I said, it's C++17. That should not be a problem. As well, like write unit tests, we have a code coverage of like 50%. All the major basic classes are copied, done, are checked. Some of more of external things that are just calculators doing input-output stuff, they're not tested as well. Which brings us to the last subject that's, at least at this moment, not fully complete. Felipe, a former, I'll just go back to here. Felipe, a former developer at the eScience Center as well, he started making a PyBind interface. Not a generic one, it doesn't wrap everything, but what it wraps is basically this object, calculator, or I think tool, data collection. Let's look, for example, QM calculator. But basically for all things that use state files, which you should know from the tutorial, QM calculators are basically the abstract type. Yeah, and basically he made a Python interface that allows you to create calculators. So you can, instead of having to use the main files, I was talked earlier about like XDP tools, which is basically the main file for like calling tool calculators. Instead, you see XDP. It basically can use the Python bindings to do that. It would also allow us to test a lot more. The pull request for that is this one at the moment, so 862. And you see there was a lot of him, a little bit of me, and Marijn is working on this as well. So yeah, feel free to reach out to Marijn as well. It's not working yet, but that's basically something that's important. If you have further questions, you can I'm still on GitHub. I'll probably also be in the developer team, but I'll do a lot less, hardly anything. But if there's some urgent, proper things, feel free to reach out to me. And I wish you good luck. And with that, I end this. Have a nice day. Good luck.